and welcome back to another episode of This Old Empire. If you remember, our current project is working on a Kevin HOLME 323 conversion of a COM-8 CSR frame. So let's go ahead and get started where we're at. Okay, so you can see we've already showed in our last episode the 323 system working, but now we've gone ahead and started adding in all the other components to get this droid functional again. Now the first thing that I'd like to draw your attention to is we've gone ahead and put in our center vent. Behind this, we have some 2-inch speakers that are about 1 3/4 inches deep. These are about the smallest speakers that we could find that would be able to work for what we're trying to do. The first thing you should probably identify is that the magnetic inducer is real close to the yoke motor control, or the motor. And here are the 3 holes that we previously talked about on Kevin's bracket, and you'll notice that the screw is not going through any of those 3 holes. We actually created a new hole. It's the exact same size, one on each side, and what we did is we moved the motor back closer towards the box by about 1/4 inch, and what that allowed us to do was gain enough clearance for the bottom speaker on the center vent, as well as maintain the motor alignment with the yoke. Moving on, still talking speaker systems. So previously I had mentioned that we had 6-inch, 3.5-inch deep marine speakers. Well, now you can see that we're operating off 6-inch slimline speakers. Now these are only about another 1 3/4 inch, 1.5 deep. So we still maintain a lot of space in here for other components and running our wires, as well as the lift motors, and without any issues. So that's our right speaker, and there is our left speaker right here. Now before anyone asks, I'm sure you're all noticing this ratchet strap that's there. The reason it is there, if you look at the droid's position, right now the droid legs are completely vertical, well, nearly vertical. But when we do practices and we want to test the 323 mechanism, that means the leg has to pivot all the way out to the 18 degrees, and that may be independent of whether the center leg is up or if it's down. So rather than having to make sure we have extra hands out here and trying to hold onto the droid or preventing it from pitching backwards, we wanted to make sure that we have a nice ratchet strap. It's pretty loose on there, but that just assures us that we can run through our functional tests without any concerns. That being said, we'll move on to the next element. So here is my 400 watt Kenwood power amp. That is for my audio system. It's got 4 channels that mixes them together, and then that moves down. And so basically I have 2 splitters, so it comes from a single headphone jack. Alright, so this is what comes from, receives the audio from the Stealth V-Music system. And then that cable then comes down. We're still working where we're going to route this to, but the braided wiring comes down, and it comes into our RCA signal filter, and that way it prevents it from having too much noise from the electricity and everything else. And that runs in and splits out to our 4 channels that goes into here. Now the only thing that's currently missing is our remote connection. I've already pulled that out because I'm working on running the cables for it, but it works well and it makes all the speakers sound absolutely amazing. The next thing we're going to talk about, I've previously mentioned in another episode that these drawer slides, alright, when the center mechanism is lifted all the way up, is equivalent of when you pull your drawer out. So the slides are all fully extended. When the leg is fully down, they're collapsed and they're at their strongest. So by having this at this position, you run into a unique challenge. So right now you can see that the yoke is at the highest position, almost. And then when you come down into 3-leg position, it would pivot down into this position. Now the unique challenge you're going to run into is when your leg center lift is all the way up for normal 2-leg, when you try to rotate the legs back, the yoke is going to hit this point. If you're running through motions like when I have it on here, you're going to potentially get stopped and go, oh, I have a problem, I don't have full range of motion. Well, realistically, you don't want your droid to have the center leg up while the legs are trying to go back in 3-leg. That will definitely lead to a faceplane. One of the things else that we've talked about is the center box. The center box of the center lift mechanism is actually what connects the center foot to the lift. Now, you could put a lot of things in there. You could put air compressors, you could put batteries, you could put electronics. In this case, I've put a subwoofer. So now we have a subwoofer that's pointed down through the base of the droid. I actually drilled 4 holes in the base of the lift mechanism in order to provide air channels to let air through. They're about 2.5-inch holes. Then I've got my right and left speakers, and then I have 2 front speakers that are paired. Now what this allows me to do is have rich, robust sound, but not necessarily blasting out at somebody directly. Alright, now let's slide over to the right. Alright, here is our Sabertooth 2x32. It has already been installed and been programmed. Quick orientation. These center wires right here are the power wires, and they come from our Blue Sea fuse box that's on the other side of the droid. These 2 wires go to the tilt motor right here, and that is how it controls the up and down on the system. And these 2 wires are for the center lift mechanism, so that's actually 4 wires that are there stacked up on top of each other. 2 wires for each of the left and right, and another 2 wires for the left and right that forms their positive and negatives. You'll just have to go through and figure out which ones are which, because all of the wires are black. I happen to match mine up because Kevin already has them paired, but I figured out which ones were which, so I made this one my negative and I made this one my positive, just so I had a convention. That's why there's blue tape on it. Alright, so moving up. The top signals, this is negative, this is positive. Again, this is coming from the 12 volts on the Blue Sea fuse panel. You also have, these are signal wires, so you have 4 signal wires coming in. One of these signal wires comes from the Arduino Nano directly above. And that is the only output, and that goes directly into the S1 fuse, S1 terminal block. The S2, the A1, and the A2 are all tied back to manual override of the 323 system. We'll get over that in just a second. Coming up to the Arduino Nano, you can see that it's on a piece of clear acrylic that has been screwed into the frame. One of the things that I've done is we went ahead and ensured that it has spacers, because a giant piece of metal and electronics didn't want to have any way for the current to be able to go through, so they're spaced off with some rubber tubing. And you can see here is our power input to the Nano. Here's our S1 output going down to the Sabertooth 2x32, and here is the 4 ground wires coming off of the limit switches, and you can see that we've gone ahead and labeled them 1, 2, 3, and 4 with some banding to make it easier to identify. They are banded on the corresponding limit switch on the other side. And these 2 wires will go over to the stealth controller, and we'll go ahead and get that wired in later, but right now it doesn't need to be hooked up. Sliding around to the side, and that then leads us over here to our variable power converter. It's just a small board that is tied into the Blue Sea fuse panel, and so it's got its 12 volts coming in here, and it has a variable controller block right here. It's just a screw terminal right there, and then we have a positive and negative output coming from that. So in this instance, we are feeding directly in, reducing it down to 9 volts. And Arduino can handle 12 volts. However, we wanted to bring it down. There's more opportunities for it to fail when it has a higher voltage. Other to note is all of the grounds that are on the limit switches must share the same ground with this power converter, because it is also the same ground that is on the Arduino. So you want all of those to share the same ground to prevent any electrical issues. Moving around to the rear of the droid, you can see that we have a Blue Sea multi-fuse panel. We have our Robotech SBL2360 motor controller. Again, orientation, there's our left speaker and a right speaker, our center left mechanism, our subwoofer. Here is our pile 24 volt to 12 volt power converter. So if you recall last time, we put our batteries in the battery boxes, and we have a series of relays in here that then feeds 24 volts up through the leg, through the shoulder hub, and down. We then feed those into these distribution posts. So we have them labeled 24 volts ground and negative or plus 24 volts. These are then linked to the right side, which has the exact same setup. So what this does is allows us to have power coming from either the right foot or the left foot, and the droid can be fully powered from it. It also ensures that the grounds between the two batteries at 24 volts are the same, and the 24 volts plus 24 volts are also the same. So that then connects into our 24 volt power converter, produces 12 volts. Here's our plus 12 volts and minus 12 volts that we then break up from there. As you can see, we're starting to run. Put our fuses in. This is just a space holder, but this is for our Kenwood power amp. Here's the Sabertooth 2x32, and this goes to our power reducer, the small microboard just around here on this back corner, right back there. So we're putting about 10 amp on there right now. We may go down to a 5, but right now 10 is what we have. Okay, sliding over. You can see we've added our fuses for the Robotech, on both sides for the power coming into it. So these are actually red wires. These are positive 24 volt lines that are coming in. These have fuses on them, and then we went ahead and added our diodes coming back the other direction so that we can provide, if there is any power generation from when we move it, it can actually have a way to get back past the fuse down towards the power distribution system. We also have another fuse that is running to a single switch that allows you to control it. Now really, all this is just a toggle. When it is on, has any kind of positive voltage, the Robotech is turned off, and then when it comes back to either, this is a 3 position, so either there or there, once it comes to neutral, then the Robotech is functional. And I just lost a wire connection, so we'll fix that here in a little bit. Alright, let's see, what else? Ah, yes, so we've been talking power. So for the battery boxes, on both the left side and the right side, we have a toggle switch, and just a little rocker switch technically, and this allows us, basically it is wired to ground, and then the signal wire that goes to back down the leg to our battery box to the relays. So when this is actually grounded and we turn it on, which is, it's in that position right now. Okay, so when you push, you even see that we labeled it. So when we push it away, so the light is up, that would mean that this switch is turned on. Alright? Now, if you were to do this right now, nothing would happen. Even though there's no batteries hooked up or anything, but if there were batteries hooked up and we turn those switches on, it would do nothing. Why? Because it doesn't actually have ground. It's just a floating wire connection. So what we have done is we took each of these wires, so these black wires coming off of our switches, right here, run over to this master rocker switch. So this rocker switch is mounted so that when you can, this is accessible from the outside of the droid if it were to get away. When you grab onto it as it's pulling away from you, if that was to ever happen, when you pull, it's going to flip the rocker switch into the back position towards the rear, which will turn it off. Pushing it forward turns it on. So in doing this, all it does is connects the 24 volt ground to this, which then connects it to the other 2 toggle switches for the battery boxes. So literally you would turn it on, and that puts ground through, which is already coming up from the batteries, and then you would turn on your switch, and this would then turn on the right battery box, which then would supply 24 volts to the droid, and everything would turn on and would start to sync. So you could either maintain your batteries and run one leg And then when it starts getting low, you could switch over to the second leg, or you could run them together in parallel. Now, the real important thing, like I said, is this was designed. There's always been talk about how do you get to a kill switch, whether it was mounted down low near the skirt or other areas, and I really never found a good spot that I liked, especially for something trying to get away. If he's in 3-leg mode, this is all tilted back, and how do you get at it real quickly? And so I wanted to go for a easily identifiable spot, so I went where one of the octagon ports is, which is right in this area. So yes, I did the unthinkable, and I cut the top portion of one of my octagon ports so that I could actually get it to it just like that, and it would turn the power off to the whole droid. The whole thing would shut down. The other thing that we have, as we mentioned previously, that we have, so my labels are coming undone. It's a little warm in here. This is our manual 323 system. So this is the rocker switch that turns it on and off. So currently it's in the off position. You tip it forward and it turns it on. So that energizes these 2 switches and this rocker. All right. So these are spring switches. So you push them and they jump back to their position. So they can go both directions. All right. This front one is tied to the center lift, so it makes it go up and down. So this makes it go up, and this makes it go down. This is to the yoke, and so when you push this one forward, the legs pull forward. When you pull it back, the legs come back. So this was if, for some reason, in one of those circumstances, your droid does not complete the conversion, you catch it, or it face plants, this allows you to get it back to a known good position and continue to work. And there's actually some resistors that are tying all these posts together. Kevin has great documentation on it, so I'm not going to go overly into it. But we went ahead and mounted it in another position, upside down, because yes, we did it for the rear pocket vent that's back here. So similarly, this toggle, this rocker switch is only accessible. I can actually only get to it with my pinky in that vent space, and so it allows me to turn it on. And then I could then do a transition, so I could make the center foot go up, I could make the center foot come down, I could make the legs rotate, and it's just to get it back to a known good. And again, this was something I did not want to have to take the whole back rear door of the droid off for, or anything else of that nature, so I just wanted to be able to get to it easily. Alrighty, let's see, what else? Oh, yes, so since I could have put electronics in the center box, because I put speakers, a subwoofer there, that eliminated that. For many of you, you may also have the COM-8 flip down panel. I no longer have space for that, and I'm also intending on putting the Kevin HOLME droid grappler, magnetic grapple. So the box goes in here and it starts coming up fairly close to this. It won't actually touch either the Robotech or the Blue Sea fuse box, but it'll come close. And then I also want to put in some gadgets in the large rear box, large rear panel that I'm also going to get from Kevin. So that meant we ran out of space for electronics, and that is a key part of any droid. So one of the things that my Cadet Con and I talked about last time was an easy way to make it accessible, but having it protected. Well, there was, as we mentioned before, there was a whole bunch of space in this area. So Cadet Connor had suggested that we make a box to put it on and then have things on drawer slides. So that's exactly what we've done. So you can see right now it is just kind of free hanging, but we already have the screws in place. We just haven't retightened it back up. So it fits right in between the yoke. The yoke can actually pivot on both the left and right side and not run into any aspect of our little box. And then we have some clear acrylic that's been cut to size and rounded, and then basically slide in. So we'll end up putting some hook pile tape, also known as Velcro tape, on a couple spots here so that you can literally slide it in or slide it out, and then it'll just be stuck on the hook pile, and that will keep it in place. And we'll do that. We have 3 drawers. I know we'll at least use 2 of them. The third one, there's plenty of space, so that you also have the slip ring that will come down through the normal slip ring hole, and it will then come down, which keeps the wires nice and close to where we'll have our controllers, our radio receivers, and all that, and it keeps it up away from all the rest of electronics, so it should have less interference and not be basically in an RF cage. So that will be exciting to do. One of the things that we're considering doing is putting the music with some industrial hook pile tape here on the side, and then we can easily just take this headphone jack connector and plug that right into it and just snake all the wires around and secure them nicely so it maximizes space, and then it'd be right here on the outside, so we could easily get to plugging it in or unplugging it. We could also get to the storage card if we wanted to change the files around without having to really dig into the droid. So again, literally our intent is to make some quick connections so we can pull things apart easily, have boards to go work on, which allow us to work external to where we're currently at right now. All right, let's see what else. Ah yes, so let's go ahead and show you. Here is the rear octagon port, and you can see my fingers pass right through, and so we'll have some black or blue gaff tape that will be on that rocker. It is a lighted rocker, so we don't want it actually showing, and so with the gaff tape no one will be able to notice it, but when you pull your finger back this way, it'll turn the droid off, and turn it this way, it'll turn it on. It provides a very quick, easy access. You can get in there without fidgeting your fingers and can grab that, or anyone could grab it very quickly, especially if you knew, your handler knew as well. The other thing, here's our rear pocket vent. So you can see this is where the rocker switch goes for turning on the manual 323 system, the override. And the first one farthest towards the leg, closest to the leg, is where the center lift mechanism is, and then here's for the moving the legs back in 3-leg or 2-leg mode. And the way we've designed this, I can literally only get my pinky in to turn that toggle switch, and then basically, or the rocker switch, and then the spring toggles barely poke down, so you can barely just get enough pressure on it to push it forward or back. And then I think the last thing is I have been asked about how I'm keeping my hubs in place. So we're just gonna pop this one out. You can see that was actually pretty easy, but I had to push from behind. So this is my hub, and you can see that it has a center screw to hold all the details together. Makes it very nice. This actually can turn. This detail pops out. So I was challenged with how do I get it on there. I'm sure most of you come through it. I know some systems have a screw mechanism to where you can actually screw it in. I've seen some people do key mechanisms, etc. My solution was magnets. So these are some rare earth magnets. They are 2 deep. I've got them in the 4 positions, north, south, east, west, and then I have corresponding single magnets on the inside of the leg. The reason they're on the inside is I tried originally at one point through trial and error putting them on the outside, but when you do so, it doesn't allow the thickness of this hub to sit properly in the leg, and it actually sticks out too far. So they're recessed on the other side, and the reason we have 1 on the inside and 2 here is when you increase the magnetic pull of the magnet. So literally just slide it in, and then you can turn this all you want. So if kids are fiddling with it, it causes no problems, and the only real way is to get behind it to get a good leverage push on it. So it's not something that's going to come out, it's not going to vibrate. I'm actually shaking this hard, and it's not moving at all, so that's going to stay put just fine. Alright, so if you guys have any questions or want to see something else on this old Empire as far as what we've done with our HOLME 323 conversion, I would be glad to address it. And what we're going to do is I'm going to hook up the power real quick just so you guys can see the manual override work, and then I will be available for questions and answers, and we'll continue to document as we move along. We'll be right back. Alright, welcome back to another episode of This Old Empire. Where we just left off, we were turning the power on so we could show the manual override for the HOLME 323 system in our COM-8 CSR frame. So without further ado, let's get started. So we've gone ahead and turned on our power supply. You can see that, let me get it oriented here. You can see that our power converter for the 12 volts down to 9 volts feeding into the Arduino is working. The 12 volts feeding the Sabertooth 2x32 is working There's green happy blinky lights, which is good. Just of note, the Kenwood power amp is not on because we still do not have the remote connected up. As soon as that does, it would start blaring music and we would have to turn it off because it's toasty and loud. Okay, so you can see all of our systems are there and we're good to go. All right, so we're going to go ahead and turn on our manual override. Okay, let's move this wire right here. And recall, this toggle makes it go up, go down. There we go. I sometimes forget. This one's to pull it back up. So let's pull it back so you can see better. So down, up. And this makes the legs go forward. And come back. And the only thing, it sounds like it's binding. It is just a little bit. It is catching on all the wood that's there on the base. So it's actually trying to shift the skirt around on my frame so it's not completely centered. But you basically get the idea. So then we can turn it off again. Alright, so if you have any questions, I would be glad to answer them for you. So definitely comment, like, and let us know what you're interested or have any questions on. I'll be glad to answer it the best I can. And we will continue doing this old Empire as we show our progress and where we try to find and put elements to our astromech. Thanks for joining us, and we'll see you next time.